Today I'd like to look at a really quick proof of the quotient rule, and this is useful for when we have one function divided by another function. So for example, maybe we have sine x over x squared. This proof will use the product rule and chain rule in them, so if you want to have a full understanding of this proof, maybe look at the proofs for those two first. Alright, we're going to start off with what we're trying to differentiate. And instead of writing it just like this, f of x over g of x, we're going to actually take the derivative of f of x times g of x to the negative 1. Those are really the same thing. But here, hopefully it's more obvious that we can actually just use the product rule. That's one function times another function. So let's take the derivative, and using the product rule, we're going to get f prime of x times g of x to the negative 1. So the derivative of the first, and you keep the second. Now we're adding the regular first, f of x, times the derivative of the second. So here with g of x to the negative 1, we are going to need to use the chain rule. We have a composite function. One of them is this power to the negative 1, and the other is just whatever g of x is. So let's use our power rule. We're going to drop this down to the front, so it'll be times negative 1. And we're also going to subtract 1 from the exponent, so that'll be to the power of negative 2. G of x to the power of negative 2. And now still times the derivative of the inside, so times g prime of x. There we go. Let's do some simplification. I'm going to flip all of these into the denominator, all these negative exponents, and I'm also going to write this as minus, because that negative 1 there will mean this is all being subtracted. So we have f prime of x over g of x minus f of x g prime of x over g of x squared. We're almost done, but it'd be great if we could put these two fractions together. So let's get a common denominator. Here we have g of x squared, here we just have g of x. So let's multiply the denominator and the numerator by g of x here. So times g of x, and that'll get us g of x squared here. And putting it all together, we have this f prime of x, g of x, minus f of x, g prime of x, all over g of x squared. And that is the formula that you might have already learned and how you might prove it. So with this example, that means we're differentiating the top and multiplying it by the bottom. So we get, if we're taking the derivative, we're going to get cos x times x squared, write the x squared here, minus the regular top times the derivative of the bottom. So the top is just sine x times the derivative of the bottom, 2x, all over the bottom squared. X squared squared is x to the 4. And you could simplify that a little bit maybe over here, but that's how you might use it.